Hi viewers, this is Sriram from KBN College, lecturer in MCA department. Today I am dealing the topic key management, which is the 10th chapter. So key management in the sense how the public keys or private keys are managed in the public key cryptography. So how will you manage these keys? Just like in symmetric encryption, we distributed the secret keys using different techniques like KDCs, hybrid KBDs, KDCs, key distribution centers, and directly distributing. So like this we are having various techniques for distributing our secret keys. So in public key cryptography also we can distribute the secret keys, and we also need to distribute our public keys, because in public key cryptography private key is kept private, but public keys has to be announced to all participants, to all the people. That has to be distributed to various people. So you have to know how to manage this distribution of these keys. So if you see, the public key encryption helps in addressing distribution of problems. It also helps in the distribution problems. Mainly we are having two aspects in this: distribution of public keys. So just I said, distribution of the public keys. In the public key cryptography you have to distribute the public keys, that is one aspect, and using public key encryption to distribute secret keys. So you have to use the public key cryptography to distribute the secret keys of symmetric key. So these secret keys are of symmetric key encryption. Okay, you have to distribute these secret keys using the concept public key encryption. Instead of using KDC concept, you can use public key encryption, because you have to believe the KDC. In those cases you have to believe some other third party person, but if you use public key encryption you don't need to believe anyone, because the private key is kept private, no one other person knows that key, so you don't need to believe anyone. So that's the reason why we can use public key encryption to distribute secret keys. So next let us see the first concept, distribution of public keys. So first of all, any user has to announce his public key, any user has to distribute his public keys, because every user, every participant in the group has to know each and everyone's public key, and private keys has to be kept private. So first of all, there are various techniques for distributing these public keys. First technique is public announcements and publicly available directory. So there is one directory maintained, that is publicly available directory, and public key authority, one authority maintains this directory, and public key certificates. The authority provides certificates to participants. So we will discuss in depth about these concepts. First, public announcement. What the user will do is he distributes public key to all the participants by broadcasting to community at a large, instead of directly telling about his public key. It is not possible, because if the group is very large, personally meeting everyone and informing his public key is not possible. So if the group is very large, he has to broadcast it to the community. So you can do this by appending PGP keys, so pretty good privacy keys, to email messages. Just like you send one message to group of people in email or Facebook. So there are different groups in Facebooks and emails, so you can just directly send to the whole group at a time. So by using that technique he can broadcast his public key. But there is one problem with this, that is a forgery. Anyone can create a key claiming to be someone else and broadcast it. So the person, if you can take an example, so if any person created a public key with the name of our Chief Minister Chandrababu Naidu, and he announces that it is a public key of CM. So by looking at the public key, people might think that is genuine public key, and they might offer different things. They might give money or give land to that particular person, give some important details. So these type of forgeries might happen because there is no authority to control. He is just announcing publicly, and there is no advisory control. There is no some control is there. So that sort of forgery might happen. Even it is simple, there is a chance of happening forgery. So until forgery is discovered, those person can do any type of damage, can masquerade as claimed user. Okay, so that is the problem with the public announcement. That's why publicly available directory. So one authority will maintain a directory. So any person, any participants who wants to distribute his public key can place his public key in this directory, so that other persons can also access to the directory and can access his public key. So for putting his public key in this directory, the directory authority will take the name, the register, some proofs, because those persons who are entering into the directory has to be genuine persons. Okay, it should not be like the earlier case, the previous case. So every person who are in the directory, in the sense they are the genuine person, because the authority is taking all the necessary proofs and everything. So we can confirm that it is a genuine public key. So what the directory will publish is the name of the person and his public key. It is like a parameter, is like two parameters, first name and his public key. The entries are like that, and all the participants has to register securely with the directory, and participants can replace key at any time. There is a chance of, because he cannot use the same public key for a long time. So if he wants to change in any way, so because of any reason he wants to change his public key, he can change. For that purpose, this directory is updated periodically. So every time, for example, for every month or for every week, it updates its public key directory, so that any new updates are there, they will be announced. So it is periodically published. So directory can be accessed electronically also. So you need not go directly manually to the public directory. So it can be accessed even electronically through your computer. You can access, but still there is a vulnerable to tamper or forge. But still there is a problem with this. The one problem with this is persons are genuine, but any user can access to that directory. There is no certain control. So the directory, so any genuine user, any user can access, and he can take and he can view any other public keys, any other person's public key. So that is the main problem. So to control that access, next concept is designed public key authority. So it is same as the previous one. It maintains the directory, but there is one person in the public key directory, that is the authority, public key authority. So anyone who wants others public key, they have to consult first the authority. It is just like a library maintenance. If a student wants to take any book in the library, he has to first consult the librarian, and only with the permission of librarian he can take any book, and every book he has taken is registered. So by doing so, books will be safe. Books will be there will be a record of how many books are taken, how many books or an issue like this, there is some control which is not in earlier case. So that's why authority is placed in a at the directory. So he has the properties of directory. So this public key authority is also having the same properties of directory, and it requires known public key for the directory. Sorry. So what the thing is, every participants who are accessing to the directory, all of them, they have to know the public key of the directory. So even the public authority, the authority person who is maintaining this directory is also having a pair of keys, public key and private key. The private key is kept private with the authority, and public key is available to all the people. Okay, so every party, you have to assume that every participant knows that public key of the authority. Okay, the user interacts with the directory to obtain any desired public key security. So every user has to interact with the directory to get any public key. So he cannot take directly, he has to interact with the public key authority. So it requires a real-time access to directory when keys are needed. So it is just like a real-time access. So not so you can't access without having any permissions like this. It is like a real-time. So if you are opening any application, you need to go to the password, login password, only then you are allowed to enter to the application. Such type of real-time access is provided in this public key authority. Now let us see the procedure followed in public key authority, how the request is passed by the sender, how it is generated. You can see it. The public key authority is having the public key and the private key. Initially the sender or the initiator will request. So he sends a request, and he also appends the time, because he sends many requests. The initiator A, the sender A, not only sends one request, he sends many requests to public authority, because for communicating with B he sends one request, for communicating with C he sends another request. For each and every user he wants to communicate, he sends different requests. So to know the difference of each request, he is appending the timer. Okay, in that request, so he mentions whose public key he wants. Okay, he is requesting for B's public key. In that request it is written he is wanting B. So public key authority reads that request, and he sends the B's public key to A. So how it sends is important. So he encrypts that data with the private key of authority. So he encrypts that data with the private key of authority, so that it can be decrypted with the public key of the authority. The corresponding key is the public key, because every participant knows the public key of the authority, he can decrypt it. And what it is in the message is PUB, that is public key of B. So the authority is sending the public key of B, and it also appoints the request and the time which A sends it to public key authority. The reason why is A needs assurance that there is no alteration has happened in the network. So by looking at the same request, in the reply, he has an assurance that it is a message for his request only. So that's the reason why the authority appends even the request and time. So now A gets the public key of B. So A sends a message to B because it gets the public key. So what message it sends is, he encrypts with the public key of B, and he sends identity of A and the nonce 1. So because he has to make B know from whom the message is coming, that's why identity of A, and the nonce is for acknowledgement purpose. So A communicate with B, but B doesn't know the public key of A to respond. So that's the reason why B also request in the same way A request. B request for the public key of A to the public key authority in the same way A requested. So and public key authority sends public key of A to the B. Now B sends a message to B encrypting with the public key of A, and in that message it appends nouns 1 which A sends and also nouns 2. So by looking at the nouns 1, he gets the confirmation B has received the message which he sent, and A replies with by sending nouns 2 to B by encrypting with the public key of B. So by looking at this message, B confirms that A has an aware of the A got awareness that he knows the public key of A. So these three steps, last two steps, are for acknowledgement purpose only. Okay, so at the fifth step itself, B knows the public key of A, but these two steps are for confirmation whether A is aware of. So confirmation purpose, these two steps. So in this way the public keys are shared in the network. So in this way the public key authority sends public keys to each participant. So this is the safest way of distributing the keys, but it seems a complicated thing because every time you need to acknowledge each and everything, because if you don't do such acknowledgements, the opponents or any, because if there is no acknowledgement like this, B doesn't know from whom the message he is coming, because he is sending the identity of A. B is coming to aware that he is getting message from A. So that's the reason why before transferring any secure data, they have to do proper acknowledgements. If they don't do proper acknowledgements, so masquerading or some other attacks might happen. So to eliminate all these complexity, another concept is introduced: public key certificates. So these certificates are just like any person who wants to distribute his public key, they request to the public key authority, and public key authority prepares a certificate for the participant, and in that certificate he includes the name of the participant and the public key of the participant. Like this, he included all the details in the certificates. So and he replies it to the participant. So the participant or the user, he can just distribute his certificate to whom he wants to communicate. He can simply communicate, because this certificate, by looking at the certificate, any user, any person can easily identify, can access the public key of that A, and also they confirms that this is a genuine public key, because that public key is encrypted with the private key of the public key authority. Okay, that can be decrypted only with the public key of the public authority. So because that certificate is authorized by the public key authority, by just sending the certificate to any participant, it is enough. So the authorization, that no need of acknowledgements, everything is not needed. Just sending a certificate to any other participant is sufficient. So that's the reason why it doesn't need any real-time access to the public key authority. You doesn't need to access every time the public key authority, public key directory. So no need to access directory. Just any user who wants to communicate with any others, they will send certificates So just looking at the certificate, they knows the public key. So a certificate binds identity to public key. So usually with other information such as period of validity, rights of use, everything. So what is the validity of the public key, everything it is written. So with all content signed by trusted public key or certificate authority, he is called, the person who signed that certificate is called the CA or the certificate authority, trusted public. So can be verified by anyone who knows the public key authority's public key. But the certificate can be verified only those who knows the public key of the authority. Now let us see the diagram of public key certificate. Initially A sends his public key to certificate authority, and certificate authority prepares certificate for A, that is CA. So CA is equal to, it encrypts with the private key of the certificate authority, so that is EPR authority, and in the message it includes the time, identity of A and public key of A. So by including all these things, it becomes a certificate, CA, certificate of A. Now A wants to communicate with B, A simply sends the certificate to B, and B can decrypt the message with the public key of the certificate authority. So since it is, this message is, the certificate is authorized by the certificate authority, there is no need of acknowledgements to the B. It simply accepts the A, and B wants to communicate to A, and B also wants a public key of A. So B wants to inform its public key to A. So B sends the public key to certificate authority and gets a certificate. In the same way A gets a certificate, and B sends the certificate CB to A. So in this way, just passing the certificates is enough. No need of acknowledgement. So that is about the public key certificates. So these are the various types of distribution of public keys. This is only about the how to distribute public keys. So you need to distribute only public keys, no need of distribution of private keys. That's why we are having topic only the distribution of public keys. Private keys are kept private. Now the next concept is the second aspect, public key distribution of secret keys. You distribute secret keys using the concept public key encryption. Secret keys means the symmetric key encryption, session keys. So you can use all the methods which you have discussed to obtain public key. To get the public key, you can follow any of the earlier steps, methods. You can use for secrecy or authentication. So you can use this for this public key encryption for secrecy or providing authentication. But public key algorithms are slow. So what the meaning is, so with the public key encryption, with the public key, you can provide both secrecy, confidentiality and authentication also. But still, most of the algorithms, most of the organizations are not using public key algorithm because the reason is slower than the secret key, slower than the symmetric key. The reason is it is the public key algorithm uses a large keys, which key size is 512 bits, more than 512 bits. So it is very powerful. Public key algorithm provides a greater security, but it is slow. So that's the reason why you have to use the public key only for a shorter messages, which are very important messages. You don't use this public key for very bulky messages. If you use the public key encryption for the bulky messages, your system becomes slow, performance becomes low. So use only for shorter and very complex, shorter and very important messages. For only that you have to use public key. So that's the reason why we are using the public key crypto system for encrypting the session keys. session keys are very important. They have to be very confidential. If that session key is disclosed, everything is collapsed. So that's the reason why such a important, because that is such an important information, you have to encrypt that with the public key. Okay, and the bulky messages like this you can encrypt with the session key, because session key is faster, because not using a large keys. So I think you understand the intention of using the public key distribution, public key. So the next topic is Diffie-Hellman key exchange. So it is one of the important algorithm in public key cryptography. So by using this Diffie-Hellman key exchange, you can exchange the secret keys using the public key encryption. This is a practical example for distributing the public key, distributing the secret key using the public key encryption. So this is the first public key scheme proposed by Diffie and Hellman in the year 1976. So Diffie and Hellman are the two scientists who devised this Diffie and Hellman algorithm, and also they introduced the public key scheme. So using some exponentials of public key concepts. We can also note that Williamson introduced the public key concept in the year 1970. So but it is not become popular. He secretly proposed this concept only, and Diffie and Hellman are the persons who implemented this concept. So it uses a number of commercial products. So this Diffie and Hellman algorithm is used in many number of commercial products. So it is, this algorithm is, so this key exchange, Diffie-Hellman key exchange, this public key distribution scheme is not for sending the arbitrary message, that is not for sending any plain text message confidentially, secretly. It is not, it doesn't send any type of message. It just distributes the secret keys. So it is just only used to distribute the secret keys. So between any two participants, what they have to do is, so the security depends upon the value of the key they had chosen, the participants has chosen. So how complex keys they had chosen, that was security is provided. So it is also based on the exponential. This is also like RSA, this is also an exponential based finite field using the prime factors, which is easier. And the security relies on the difficulty of computing discrete algorithms, similar to factoring. So just like factoring, so you have to calculate the discrete algorithms, which is harder. Now let us see the Diffie-Hellman setup. So all the users agree on some global parameters. All the users who are participating in the distribution, they have to arrange some global parameters. So they have to first choose the large prime number or a polynomial, which is q, and they have to calculate the value which is a primitive root of modulo q, that is a. So they have to calculate a value which is a primitive root mod q. So like just like 4 prime, they have to take, so they have to calculate the a value, the mod q. So each user generates their keys. For example, user A chooses his private key, that is secret key, like XA, which is less than Q. So XA is the private key of user A. So here you have to think X is a private key and Y is a public key. So XA, he has to choose of his own, any of the number he has to choose randomly. So XA is a private key, and how public key is computed is, so public key is YA. YA is, you have to do exponentiation using the primitive root A. So A power XA mod Q, then you will get the public key. If you calculate A power XA, that is A power public key, private key of A modulo Q, then he gets his public key. The same way B also has to choose his secret key and calculate the public key, that is XB and YB. Each user makes public key by A. So now let us see how the key exchange is happened using these public and private keys. So they have to share and distribute the value, distribute the secret key KAB between the participants A and B. So KAB is the secret value or the session value, session key, which they have to distribute. So they doesn't distribute using any channel. So they will just calculate some discrete mathematics and find out a value which is a secret key or a session key. So the same value is generated for both sender and the receiver. The same value is generated. So let us see how it happened. So KAB is equal to A power, that is primitive root power XA XB, that is private keys of respective users, private key of A, private key of B, modulo Q. So how they will calculate is, for example, how the B computes. So we know the public key of A by A. So public key is known to anyone, and he does the exponentiation XB, that is his private key. This private key is known only to B. So he calculates public key power, public key of A power, private key of B modulo key. Public key of A power, private key of B modulo key. Then he gets a session key. The same calculation is done by the A. So he calculates on the B's public key, that is YB. YB power XA is private key, YB power XA modulo key. So if they calculate these values, both of these will get the same value. That value is a KAB. So because both of them are having the same value, so they use that value for the confidentiality, for encrypting any messages. So KAB is used as a session key and private key encryption between Alice and Job, Alice and Bob. So this KAB is used as a session key. If both Alice and Bob subsequently communicates, they have to use the same key as before. So repeatedly, if they have to communicate, they can use the same session key which now they have distributed. But if they want to change, they can change by changing the value of public key. They change the value of public key and private key, the key also changes, and they can produce the same key value between A and B. So here what the attacker need is, he needs the value of X, that is private key. So if the attacker knows the X value, then he can decrypt the session key. So this is how the key is exchanged between any two participants. So now let us see practical example of this Diffie-Hellman. So user A and Alice and Bob they want to swap their keys, that is they want to distribute between themselves. So both agree on the Q 353 and A is equal to 3. So first of all they have to agree two values, Q 353. These two values are known to anyone, even the opponents, because these two values are transmitted in the network. Even the opponents know these values, they cannot find out the session key because the private keys which they had chosen. So the session key depends on the private key they had chosen. Because the private key is not known by opponents, they cannot find out the session key. So A chooses his private key 97 and B chooses his private key 233. Now they have to compute their public keys. How they will compute is YA, that is public key of A. He computes on the primitive root 3 power 97 modulo 253. Then he gets 40. This is a public key. And how B gets the public key is YB is equal to primitive root power his private key. His private key is primitive root 3 power 2 the 33 mod 353. The value is 248. So these two are the public keys of Alice and Bob. Now he has both private key and public key. Now we can distribute. We can generate the session key and distribute it. So how the Alice gets a session key is uses the public key of B power private key. So public key of B power his private key modulo 353. So that is public key of B is 248. Private key of A is 97. So you get the value 160. The same way Bob also calculates. So Bob knows the public key of A. So public key of A power is private key. So public key of A is 40 power 233 mod 353 is 160. So you will get the same value. So by without sending this 160 this key value in the network channel, so both can generate the values. So this is the concept of Diffie-Hellman. So in this chapter we discussed about how the distribution of public keys, how you will distribute the public keys. So various techniques, and public key distribution of secret keys, how the secret keys or session keys are distributed using the public key concept and the Diffie-Hellman key exchange. How will you exchange key using a Diffie-Hellman algorithm? So thanks for watching this video.